Καλημέρα σε όλους. Good morning. I will try to support what Judge said just now with a little bit more practical examples. Starting with our views. 2016 was the overdue year. What happened now should have happened earlier, we guess. The convention has been ratified. Many predictions have been verified. A lot more have not. There are still many predictions which we expect to see how they will be finally verified or not. So we are happy to present our views here. About this year, we can say that it will be the year where many issues have to be clarified. First of all, I would like to say that we have accepted that this delay was needful. In reality, no stakeholder in the market was ready to serve their purpose. The reasons are many. I wouldn't spend more time to explain them now. So we all wait this year the planning of the vendors, of the ship owners, and the flag administrations, and see how we will proceed. I like to evaluate things comparing certainties with uncertainties. So now I think we have more certainties than uncertainties regarding the ballast water treatment market and project in general. We have the ratified convention. We have finally US Coast Guard type approval system and more to come. We have revised G8 guidelines. I like to pinpoint some other smaller issues, but important for the market. We know that due to the early IOPP renewals, there will be very few retrofits after the ratification in the first months or the first year after ratification, the entry into force of the convention. We know that US Coast Guard extensions for dates after 2019 have been put on hold, and we know and we believe strongly that there will be installations starting 2019. The uncertainties, we don't know the final implementation dates. We don't know how the US Coast Guard type approval procedure will be harmonized, or if it will be harmonized somehow with the revised G8 guidelines. And finally, I would like to pinpoint one other uncertainty, which I will focus on the rest of my presentation using an example. People are not in position to fully specify, calculate the cost of this project. So, for us, the big unknown for this project is the budget. And we believe will remain unknown until we have the experience of this project. So we receive many questions regarding the cost and only. How much is the cost of the installation? How much the systems will cost now in the future? How much the materials cost? How can we make it cheaper? To discuss this issue, I would like to present a real case, the story of 3 sister vessels, which we had the experience to study and retrofit recently. We present them because we can compare the first projects with the second, because the first 2 ships have been retrofitted before the third one, which was NS Commander. NS Commander is a ship managed by SCF Novoship. It is an Aframax. It has 2 sisters, NS CONSUL and NS CENTURY. Those ships, retrofitting has been prepared by Argo Navis. Just to present the timeline of the project for you, the actual timeline, feasibility studies for various systems have been carried out for various ship designs of the company, approximately more than 1 year, in 2014, 2015. The company has selected the system to install in various ships in May 2015. We have carried out 3D scanning and space evaluations in November 2015 for this particular series of ships. The preliminary engineering has been carried out last December. The documentation package has been submitted to DNVGL in March, and the detailed engineering has been finished in May 2016. Finally, the actual job of the 3 ships have been carried out from August, not till November, till October 2016. The equipment chosen was EcoChlor for those ships, chemical injection system. The job has been done in Tuzla TK shipyard. First, the 2 ships, NS CONSUL NS CENTURY, then NS Commander. The shipyard used the same project number at least for 2 of those ships and the same subcontractors. From the first 2 ships, we've learned a few things, and we have used them in the second, in the third one, actually. The shipyard did not include commissioning in the first calculations of their job. We have done scan to 1 ship. That caused a few small problems. Time was spent for yard to train their subcontractors for GRE piping. The shipyard underestimated the electrical and automation workload, and all of us have underestimated the problems with interconnection of the system with the existing systems of the ship. Finally, DNV used 1 surveyor for 2 ships. That was not a big problem, but I just mentioned it. Final duration was 32 days. So the third ship, I will try to just describe roughly how the job was done. We had some prefabrication, not very extensive prefabrication, the same with the first 2 ships, some panels for the deck house, some foundations for filters and the system, pipes. In the first week, we had the preparation of the job and the planning, unpacking of items, transfer of big components in their final positions. You see here the filter for serving the after peak, transferred in the engine room. This is one of the main filters installed in the lower part of the pump room. In the second week, we had installation of the tanks in the deck house. We have cleaning and cables, pulling, piping, wiring. Few photos, you see the main unit installed inside the deck house, piping inside the pump room, and of course, automation and cabling. In the week 3rd, we have the completion of the job. This is the deck house as it can be seen from outside. The installation for the after-peak tank, the injection lines. Finally, we had the commissioning, and we managed to finish the job 6 days earlier to have a certificate, and we calculate that roughly there was a saving to 15 to 20% of the cost, of installation cost, of course. We believe that we can manage to have budgeting, correct budgeting and savings after there are proper partnerships and experience. Before we have this, before we achieve this, I think budgeting, no matter how much time we spend, will not be very successful. This is our presentation of the day. Thank you very much.